Well, thank you very much for having me today. I think this is a great session, a lot of great talks today. I'll talk to you about our Brackish groundwater characterization program that we've been working on at the Water Development Board for about the last 4.5 years. This is our legal disclaimer that we're supposed to put in all our slideshows now. This is the 2060 water plan indicated that 2% of the groundwater desalination is going to be that slice of the pie anticipated for about the next 50 years of growth within the state. So it's a very, very small part, but if you're in that part of Texas that is relying on groundwater desalination, that may be 100% of what you're actually trying to produce. So we have an awful lot of information in the state about the fresh and slightly saline groundwater resources in Texas. And the reason I kind of indicate the slightly saline part is that most of the major minor aquifers that are portrayed on these two maps are mapped from about 0 to about 3,000 milligrams per liter in total dissolved solids. And brackish groundwater starts at about 1,000 and goes all the way up to about 35,000 where seawater would be in. So we understand the major minor aquifers and the fresh and slightly saline resources quite well because that's where most of the water wells have been drilled. People are going for the best quality water and the best quantity water across the state. Brackish water, though, is not really new and innovative because it's been used ever since people have been living within the state, going all the way back. In fact, the first well at the Texas State Capitol was brackish. And so you can see that the Texas legislature has been really funding brackish water development ever since its inception as well. So this particular map shows kind of the distribution within the major minor aquifers of the brackish resources across the state. So everything in yellow and a few of the small little dots that you might see on that map represent what we believe are the extent of the brackish aquifers in the state. Now, this particular map is looking at brackish from the standpoint of about 1,000 to about 10,000 milligrams per liter. That's about the zone where it's the cheapest to treat that water for, say, municipal use. You can extend the maps out to 10,000 all the way up to 35,000, and more of the state would be underlain by the higher salinity water. So to kind of get a better handle on the brackish resources, from, say, a municipal development or industrial development standpoint, we conduct multi-county studies across the state, and this map shows on the left the brackish studies that we have completed, one in the Pecos Valley and one in the Atascosa and McMullen County area for the Queen City Sparta aquifers. And we're finishing up a study for the Lower Rio Grande Valley. And we've also got an ongoing study looking at the Carrizo-Wilcox in central Texas. On the right side of the map shows in solid diamond symbols the current desalination plants for municipal use across the state. And then we've got all the open diamond symbols which represent the recommended desalination projects that were put together, put forth by all the regional water planning groups for the 2012 State Water Plan. So we're trying to match up our studies with parts of the state which have recommended between now and 2060 they want to get into brackish groundwater development for municipal use. So we had the highest cluster of potential plants down in the Lower Rio Grande Valley, and especially with the drought that is occurring and the push water issues and trying to get water to some of these municipalities. This particular study is very timely. Now, in order for us to do these types of studies, we have to collect a lot of information. As I said earlier, we understand the fresh and slightly saline resources quite well, but if we start to extend our knowledge of where that brackish water is, either farther down dip, deeper, and below some of the freshwater aquifers, we have to collect all this information. So we collect a lot of geophysical well logs, primarily developed for the oil and gas industry. We put these together into a geologic database. We do a lot of GIS analysis to try to develop three-dimensional surfaces to try to figure out, at what depth, what volume, where the sands are across the state. To collect all the water quality data that we can get our hands on. And at that point, we can begin to estimate some of the volumes of the brackish water. Now, the numbers that we get for the volumes are good from a management standpoint, but it really, when you get into the standpoint of trying to develop an actual well field for a municipality, we recommend and wholeheartedly you have to start drilling the test wells to really try to determine what that deeper, more salient aquifer is really willing to produce. And I think JP Nicole mentioned it in his earlier talk that since we haven't developed a lot of these water resources in that higher salinity water in parts of the state, we don't know enough about that. There's only so much that we can do from the Brackish characterization program using existing data, and then we have to rely upon some of the consultants and municipalities to then go out and do the test well drilling to really prove up what those aquifers can produce. Another aspect of that is that because of the variability of the aquifers across the state and the data availability across the state, each of our studies we kind of have to tailor and tweak a little bit to meet those site-specific conditions. So the typical project deliverables that we will have for a study is a published peer-reviewed report done through the Water Development Board. We provide all the GIS data sets. They're available on our website. We put all of this information into our BRACS database, which is a custom database that I'll talk about in a moment. And then we provide all the raw well data that we've used to do this study. I want to kind of mention at this point that even though we put together this peer-reviewed report, the real value is in the data. You know, the report can summarize the methodology that we go through in a study and has a lot of nice 8.5 by 11-inch maps. But when you get down to really trying to understand that part of the study area and can we develop a brackish resource for, say, a municipality, the real value is getting into the data, the well logs, and the GIS information that the consultants and stakeholders will use to try to, you know, figure out the parameters that they would need to meet that municipality's need. So one of the things that we do for these studies is we collect a tremendous amount of well control. So our Pecos Valley study that we did in West Texas, the blue dots represent the existing water well control that we had for the study, and then all the red dots refer to all the oil and gas logs. So this particular study, we had about 5,000 data points, about evenly distributed between water wells and oil and gas wells, in order for us to define the three-dimensional aspects of that aquifer and then try to map out the different water quality zones in that study area. With respect to the database, on the left side of the screen, we have a Water Development Board groundwater database that's been used for many, many decades. We've got almost 140,000 wells in that database, which try to describe the major minor aquifers across the state. But that database didn't really have all of the information and all of the tables that we needed as we begin to define the brackish resources. So on the right side of the screen, we list all the different types of tables that are available within the BRACS database. So, you know, we're tracking all the raw data. We're putting all this information into tables, so we're tracking the tops and bottoms of formations, the different hydrochemical zones within the formations, aquifer test information, the productivity of the aquifers, all the water quality data goes in, and then all the net sands. And basically the net sands, if the water is in the sand, we use that for the volumetric calculations. And then we wrap all this information up and provide that as a deliverable, you know, to the stakeholders. The database is a Microsoft Access relational design, so it's pretty standard. You don't have to have any fancy software if you need to download that. It's available on our website with supporting information. One of the nice things about the database is that it has hyperlinks to thousands of the geophysical logs and the water well reports that we use for the study. So you're not trying to search through 40,000 records in different folders to get the information tied to a particular well record. And then we do all of our analysis within the Access database as well using Visual Basic Code. And so that's kind of very handy for us to have it all in one place. The other advantage to this particular data design is that all these water wells and oil and gas wells have different IDs and names and keys associated with them. And by tracking all of these different unique IDs, we're able to link up and match with many, many different existing data sets across the state. So we can tie into a Railroad Commission database of about 1 million oil and gas wells. We can tie into the different water well databases across the state because many of the data pieces of information that we use also have other data in these other agency data sets. So it was very apparent to us when we first began this project that we needed to start collecting geophysical well logs. We were able to get a little bit of funding from the legislature to then get a contract through the Bureau of Economic Geology to help collect this information. So at this point, we've got about 43,000 logs within the data set, kind of represented by all those blue dots. If we don't have a digital log available to us, we'll go ahead and scan them into a TIFF format. And this entire log collection is available to the public, and it's also available free of charge too. So if you want the whole state or if you want just the county, we can go ahead and provide that. And we've done that many, many times with a lot of the different consultants across the state. The logs are very handy because what we can do is not only evaluate the geology and the formation tops and aquifer extents and so on, but based on the types of tools, we can also try to interpret what that deeper resistivity signature would be, and then try to tease out from that resistivity signature what the interpreted total dissolved solids content might be from this. So in this particular example, the yellow would represent sands, and the different red bars represent a different resistivity value that's been interpreted. So in this situation, we've got very saline water that lies on top of moderately saline water, and then we've got some slightly saline water near the bottom of the log. As you were to go deeper, if I had enough room on the screen, that transition would go kind of backwards, and we would get more and more saline water, and then eventually brine in the deeper parts of the well. So we use these logs for a variety of geological purposes in the study. So I'll show you a few slides from the Lower Rio Grande Valley study that we're currently working on. This particular map of about a 4-county area in the southern part of the state indicates that we've got about 21 different zones across the study area, each one represented by a different letter. And in each one of those little polygon areas, we've got a different salinity profile. And so area A, we've got moderately saline water over very saline water and so on. So what we've gone and done in the study area is try to map out 3D extent of all these salinity zones, which are represented kind of diagrammatically by the table at the bottom. And this particular study area, I think, was a lot more complicated than we even anticipated. We've got not only natural saline conditions, but we've got, I think, a lot of anthropogenic overprinting in that region too. So we've got irrigation water that is leaked in that's making some areas a little bit fresher than they would be. We may have some oil and gas activity with some form of produced water disposal, which may have saline pockets kind of near the surface. But by putting all this information together, I think it's going to be a terrific product for stakeholders to then go in and say, where's the best place to then go in and develop water resources for the valley? So some of the data sets that we provide, this is an indication of the slightly saline deep zone. It's basically representing from 1,000 to 3,000 milligrams per liter in total dissolved solids. And so for a large part of the area that's hashered, that zone starts right at the ground surface. So we don't have to go down 2,000 or 3,000 feet to actually get that resource. We can then go in and make maps of the total thickness of this particular zone. And we've also got maps which will show the total net sand content, or how much of that formation actually contains water-bearing material that you could then put a well into and then extract out the water. So these are just some of the products that we would put together in our particular studies and then get that out to the stakeholders for future development. So in summary, our goals are really to kind of take a look at the quantity, the quality, and a very fine scale distribution of where that resource is within a project area. There are significant areas of the state that need to be evaluated. If you remember that slide earlier in the talk, we've only done a few projects across the state. We've got the rest of the state to do, so it's kind of job security, for some of our folks. These studies do take a lot of time to do. We've been very fortunate. The legislature has gone ahead and funded as much as they have in order for us to do these projects. We're currently evaluating different techniques that can be used to look at this information to kind of get a better product. And then all of the information that we put together is available to the public, and that's kind of one of the tenets that the Water Development Board has done for all the decades in its existence, is to get this information out to the public so they can use it and they can flip it and try to interpret it as well. So these are some contacts, and if you've got any questions, certainly get a hold of us. If you don't want to do it today, we're available by phone or by email, and we do office visits and all kinds of things. So thank you very much for the opportunity to speak to you today.